The long journey ahead to Uranus. Uranus, 7th planet in the solar system in order of distance from the Sun, 3rd in diameter and 4th in mass. Average distance from the Sun, 2.871 billion kilometers. Orbital period, 84 years. Equatorial diameter, 51,100 kilometers, exactly 4 times that of Earth. Mass of 14.6 times that of Earth. Rotational period, 17.25 hours. Minimum temperature, minus 226 degrees Celsius. 27 satellites detected so far. A hostile and violent world. Already flown over by one of our probes many years ago. A world full of mysteries. And we are about to return to it. Above us, hidden in darkness, the blue giants Uranus and Neptune are claiming our attention. Much larger than Earth, than Mars, than Venus, yet so distant as to be invisible to the naked eye. We encountered them only once when Voyager 2 flew over them in 1986 and 1989, then passed on until they were lost in interstellar space. Numerous other probes since then have visited all the other planets in our system, but the blue giants have not. They have been kept on the sidelines, even though we have long known that in them lies the key to understanding how our solar system, and especially the solar systems of other stars, came into being. Now, however, there seems to be a desire to return to Uranus, and that is a good thing. Countless, in fact, are the mysteries surrounding the 7th planet in order of distance from the Sun. Uranus is characterized by a rotation around its axis, unique in the solar system, an atmosphere agitated by winds at extreme speeds, and an extremely complex magnetic field, all phenomena whose origins are not well understood. It is also unclear in what part of the solar system it was formed, whether it ever exchanged positions with Neptune in the system's turbulent early stages of evolution, nor what its exact composition is and how extensive its rock and ice core is, while it is suspected that some of its major satellites, Ariel and Miranda, which show signs of geological activity, may harbor oceans beneath their surfaces. If we tell you this, it is for a very specific reason. But let us first do a little history, just to get a better understanding. From the beginning of time until the evening of March 13, 1781, human beings knew of only 5 planets, those visible to the naked eye and now bearing the names Mercury, Venus, Mars, Jupiter, and Saturn. Although it is also visible to the naked eye, like the other 5 planets known since antiquity, it was not recognized as such and considered a star until the 18th century because of its low brightness and particularly slow orbit, and was identified as something other than a star only on March 13, 1781 by William Herschel. Curiosity about his discovery is that it came completely unexpected. Planets visible to the naked eye up to Saturn had been known for millennia, and no one suspected the existence of other planets until Herschel's discovery, who noticed that a particular low luminous star seemed to be moving. From then on, no one was sure of the real number of planets in our solar system. That was until between 10 and 11 o'clock at night on that March 13th, the Anglo-German astronomer William Herschel spotted a small blue-green disk in his telescope. Following it and noticing day after day that it moved across the sky, Herschel was thus the first human being to reveal that new invisible worlds orbited the Sun. Or at least so the encyclopedias say. But was Herschel really the first to see Uranus? No. Other astronomers in previous decades had seen it, but all had mistaken it for a star without having the patience to observe whether or not it had its own motion and moved on. Instead, Herschel was the first to identify in that fuzzy little star a moving object. But did he immediately realize that it was a planet? No again. At first, he thought it was a comet, like the ones his sister Caroline discovered, and it took long periods of observations to get enough data to construct its orbit and to confirm that after millennia, the solar system had been enriched by another component. Like Earth, Uranus and Neptune are blue worlds. Neptune, on whose globe of marine color run white clouds, would also seem to the casual eye to be a clone of our planet. The blue of these planets, however, is not that of an ocean, but is the color of methane inside an icy atmosphere of hydrogen and helium at 220 degrees below zero, the coldest places in the solar system. Their strangely terrestrial hue, so different from the orange-red seething of Jupiter and Saturn, tells us that while they are two giant balls of gas, they are actually quite different from their larger cousins. Like Jupiter and Saturn, in fact, Uranus's atmosphere is full of hydrogen and helium, but with abundant presences of methane, ammonia, water, and hydrogen sulfide. Methane gas absorbs light in the red part of the spectrum, giving Uranus its blue-green hue. If you flew down through the layers of the atmosphere, the surrounding clouds would become denser and denser, colder and colder, bluer and bluer, as the gases absorb more of the visible spectrum. And beneath the atmosphere might be found the answer to another of Uranus's great enigmas. Its unruly magnetic field is tilted 60 degrees from its axis of rotation, much stronger at one pole than the other, and shifted a few thousand kilometers from the center. Some astronomers believe the warped field may be the result of vast oceans of ionic liquids hidden beneath greenish clouds, filled with water, ammonia, or even liquefied diamond. The two blue giants have their own distinct personalities. When Voyager 2 flew over Uranus, its photos amazed astronomers, not because of what they showed, but because of what was missing. No bands, storms, spots, or clouds, just a homogeneous pale turquoise sphere. Only by altering the contrast of the images could very thin clouds be discerned. Today we know that in fact Uranus is not so calm, thanks to infrared observations, and later telescopes have noted that storms have arisen, but it remains the most serene giant among the planets known to us. On Neptune, however, no apparent calm. It blows the strongest winds in the solar system, 1,700 kilometers per hour, 3 times the strongest wind ever recorded on Earth. Storms and bands and clouds are clearly visible, and all this turbulence keeps Neptune bright blue. In fact, Uranus is faded because of a permanent photochemical smog, which on Neptune cannot accumulate due to the stirring of the atmosphere. But what is the reason for this difference? Well, apparently the reason lies in the fact that Uranus is the planet that releases the least internal energy in the entire solar system. That heat that burns at the center of the planets, a relic of their formation. Uranus either does not transmit its heat or it has lost it, and both options involve more questions than the answer. There is one possible solution, and that is that the interior of Uranus was disrupted by a giant impact. This would also explain one of the planet's most bizarre features. The axis of Uranus is tilted relative to its orbit by 98 degrees. It's basically lying down, like an inverted spinning top rolling on a table. This causes Uranus's poles at the solstices to look alternately straight towards the sun, and are thus the places with the longest known days, 42 years of sun followed by 42 years of night. The most immediate explanation is that Uranus was knocked down like a skittle by another celestial body as big as or bigger than Earth. In fact, today some speculate that both Uranus and Neptune were struck in their infancy by planetary-sized bodies, Uranus by a smear while Neptune in full. If so, it would be confirmation that the entire solar system was sculpted at its origin by immense cataclysms. Which ones? Today we know that the planets we know are unlikely to have formed in the orbits in which we still find them. This is told to us by the moon we have in the sky, most likely born from the remains of the crash of a planet the size of Mars with the primordial Earth. This is told to us by the fact that 3.8 billion years ago, young but now formed planets suffered an immense asteroid barrage, the so-called Late Heavy Bombardment. Computer models also tell us that billions of years ago, the giant planets performed a complex gravitational dance before arriving at their present orbits, hurling asteroids around like gravel kicked by a child. According to some of these models, during the formation of the solar system, Neptune was closer to the Sun than Uranus, and all the planets were still much closer to our star than they are now. The only way to understand what really happened is to see whether the blue giants have retained traces of their past history. For example, to understand whether they formed where they are now or in warmer parts of the solar system. But it doesn't end there. Uranus and Neptune are surrounded by a large number of moons, also among the most exceptional and mysterious in the solar system, as well as thin rings. We associate the word moon with the idea of a dead, gray body like our own, but the major moons of Uranus and Neptune appear to have been active. The 5 major moons of Uranus, Miranda, Ariel, Umbriel, Titania, and Oberon, are bodies of rock and ice between 500 and 1,500 kilometers in diameter that, in the few grainy images sent back by Voyager 2, often show signs of active geological phenomena and a young surface, capable of sculpting valleys and escarpments like Miranda's Verona Roots, the highest abyss in the entire solar system. A place where one can launch oneself off a 20-kilometer high vertical cliff and fall with exasperating slowness for 12 minutes before hitting bottom. What really happens, however, on those moons, we do not know. The moons of Uranus tell us that, as opposed to the hot geology of the terrestrial planets made of lava and rocks, there's also a cold but no less interesting geology drawn by ices and oceans of water, methane, and ammonia instead of mantles of molten rock. All features have always been considered interesting, though not intriguing enough to merit special attention, until astronomers began studying planets around other stars and discovered that ice giants like Uranus and Neptune were everywhere. In short, there are plenty of reasons to visit the blue giants again. So much so that the U.S. National Academy of Sciences recently issued a report urging NASA to plan as soon as possible to send a probe to Uranus. And that means that in all likelihood, the next high-profile mission will be the one that finally brings a probe into orbit around our home planet's most mysterious and most underrated planet. A mission that already has a name. It will in fact be called Uranus Orbiter and Probe, and it will aim to put a satellite into orbit around Uranus, which will observe in detail the planet's characteristics for several years, while also launching a probe into its dense atmosphere. Of the proposed missions, Uranus was chosen because over the next 10 years, there is no possibility of a useful trajectory for sending a probe to Neptune. In the case of Uranus, on the other hand, there would be 2 possible windows, in June of 2031 and April 2032, both with the possibility of exploiting Jupiter as a gravitational slingshot for a journey of about 13 years. To reach the goal, the mission would have to be approved and development work begun by 2024. Other launch windows between 2032 and 2038 would require trajectories to the inner planets in search of other gravitational assists, and the trip would take more than 15 years. That leaves NASA a decade to design the probe and raise the $4 billion needed to build it. We're not talking about tomorrow. We will have to wait more than 20 years before we receive images and data from such a distant world. By that time, we should have landed on Mars and put permanent bases on the moon. It will be an era of exciting achievements. Let's keep our fingers crossed then, and let's all look forward to those happy days in the future.